Okay, now we're going to do quadratics, which is chapter 1 of the purple functions and stats book. Start off with a bit of terminology. Here is a quadratic or a parabola, and we have the place where it cuts the y-axis, that's called the y-intercept. Where it cuts the x-axis, there's two of them here. They are called either zeros, sometimes they're called x-intercepts, sometimes roots, sometimes solutions. There's subtle differences between those four terms, which we'll see later in the course. Down the bottom we have what's called the vertex or the minimum. Sometimes it's called a turning point, and that lies on the axis of symmetry, which is the line splitting the graph into two symmetrical parts, so it's like a mirror image. Okay, so first of all we'll go down and have a look at the investigation, and I'll just summarize this. First of all, they're saying to sketch these graphs. They're x take 1, x take 3. Now x take 1, x take 3, that's repeated all the way through, but all they change is the value out the front. So here it's 1, here it's 2, here it's minus, which really is really a minus 1, here's a minus 3, and really it's asking what is the significance of A, where A is the bit out the front. So let's see what A does. Now to do that you use the graphics calculator. So I've already entered the data, the functions into the calculator. So here's the first one, x take 1, x take 3. We'll have a look at what that looks like. Now if you just press graph, this is all in the y equals, by the way, that button there. And this is bold, so it will only plot this. If your plots are bold, then it's trying to do the function and the statistical plot together. We only want to do the function, so unhighlight any of those plots or any other functions. Now if you press graph, it may not be the best window range. We can see we've got a parabola, but we'd like to see more of the left. So we've got to change the x minimum down a little bit lower and the y minimum down a little bit lower, so we can see most of this graph. So press window, and the x-min we could take down to minus 10, so going from minus 10 up to 10 on the x-axis. And for the y, we want to see more of the bottom part of the graph, so we'll take that down to say minus 5, and we don't have to go all the way up to 63, we could just go up to say 30, and then graph, see what that looks like. So we can see it cutting here at 1 and 3. You can press the trace key to have a look at the values. So you can see when it cuts the x-axis, it's roughly about 1 there on the x for the x value. If you want to get the exact value, you go second calc value. This will do any particular x value. If we guessed that it was 1, we'd type in 1 and press enter, and see it says when x is 1, y is 0, so that's the x coordinate. If you didn't know that, then you would just go second calc and you'd choose the 0, and it goes to the says go to the left of the 0, press enter, go to the right of the 0, press enter, then a guess, and it jumps to it and says 0 is x equals 1. We could do the same for the one on the right to get the two x-intercepts. So it turns out to be 1 and 3. And the reason why it's 1 and 3 is because there's 1 here and there's 3 here. So when x is 1, if you put x is 1 in there, then this whole bracket is 0, and so y is 0. Or if you put x equals 3 into both of these, then that bracket will be 0 and the whole thing will be 0. So that's why the x-intercepts correspond to the two numbers in the bracket. Okay, now we'll look at the effect that the A in the front has. So I'll go back to y equals, and this time we're going to now see what this 2 does. So I'm going to now highlight this second graph and plot these two together. So there's the graph of the 2 out the front, so it's made it narrower. Notice the x-intercepts are still the same. If we go back and now put in something smaller, like let's put in say -0.5 out the front, and graph that one, then it's actually wider, but once again still goes through 1 and 3. So we can say that when the A value is large, like 2, it's narrow, and when the A value is small, like 1/2, then it's wide. The other thing is you've got these negatives. You could have a negative out the front. So to look at the effect of the negative, if we put say -2 out the front, and see what that does, it flips it upside down. Oh, I'll go back again, highlight that, bold that equals, and see what that looks like, and it comes upside down there. It's that pink one. Once again goes through 1 and 3. It's the same width as the red one with the 2 out the front, because this is now -2. Okay, so putting all that together in a summary, we can therefore say that when you've got y equals A, we'll put x take alpha, x take beta. In our case it was 1 and 3. This value out here, this affects the shape of the graph, where if A is positive, you get a smiley looking graph. If A is negative, you get a sad face looking graph. And also when A is bigger, then it's wider. So we can say the larger the A implies that it is narrower, and the smaller the A means you are wider. Okay, these ones here, these values here, give the x-intercepts. So we'll just write in here x-intercepts. In our example it was 1 and 3. Okay, now we could actually explain why the A values give this narrower and wider with an example that we just did on the calculator. We'll have y equals x take 1, x take 3, and we'll compare that to y equals 2, x take 1, x take 3. Now we could set up a table of values for the first one, and we'll go -2, -1, 0, 1, 2, and we'll do 3. Now when we put -2 into the x, -2 take 1 is -3, -2 take 3 is -5, -5 times -3 is 15. When we substitute -1 into the x, we have -1 is -2, -1 -3 is -4, -4 times -2 is +8. If you put 0 in, you'll have -1 times -3, which is +3. putting 1 in. 1 take 1 is 0, so that wipes the whole thing off at 0. That's why that one is the x-intercept. If you put 2 in, 2 take 1 is 1, 2 take 3 is minus 1, those multiplied together is minus 1. And if you put 3 in, you'll get 3 take 3 is 0, and the whole thing is 0, so that's the second x-intercept. Now, doing it for the other one, where we use the same x values, if you put in minus 2 into there, we've already done it up there, we'll get 15, but then you've got to times by 2, so you've got to double it. Same here, you put minus 1 in, you'll get 8, but you've got to double it. So basically everything is doubled, except the zeros, because doubling 0 is still 0, that's why you still get the same x-intercepts. If you double that one, you are minus 2. Okay, so that's why when this number here gets bigger, I'm talking about the modulus of that value, so in other words, minus 3 we say is bigger than minus 2, but here we're just dealing with the positive. That's why when the number is bigger, you will have a narrower graph, because if we started plotting these, let's plot the first one, you go minus 1 and you go up to 8, minus 2 you go up to 15, so it's coming down like this. 0 is 3 and 1 is 0, and it goes like that. But when you plot the second one, you can see because the values are a lot higher for the y, when it's minus 2 you don't go to 15, you go up to 30. It's basically double. So doubling the values has the effect of narrowing the graph. So it comes down through the same x-intercepts. So that's why when the a value out the front doubles, the thing narrows. Notice all these values here I did manually. You can get those values off the graphics calculator by doing this. You could go second calc and you go value, and we could do when x equals minus 2 equals, and it gives you 15. Another way of getting the values would be using the table. Go second table, and there's all your values there for all the different graphs we've put up. So when x is minus 2, the y value is 15, whereas in the other one it's 30, it doubles. Okay, and just to prove that the alpha and the betas, the numbers in the brackets, are the x-intercepts, we can have a look at this one here, which should cut at 1 and 4. So just bold that one, press graph, and it comes down cutting at 1, but this time it goes over and cuts at 4. If you want to see which one we're talking about, press trace key. You press the up and down to jump between all the different graphs. So the black one, minus 1, minus 4. So it cuts at 1 and cuts at 4. Okay, so that's an intro to the quadratic graphing.